Hey you guys, this is the Algebra 2 video for the Chapter 7 study guide. So it says refer to your notes for help. So hopefully you already went through this and you tried all the problems on your own and you're just watching this video for the problems that you couldn't figure out. Alright, so number 1 says graph the exponential function. In order to graph these exponential functions, we need to make a table. Alright, so I'm going to create this XY table. And remember, you can use any numbers that you want to. Typically, you use about 5 numbers that you plug in for x. I'm just going to pick 4. And the 4 I'm going to choose is -1, 0, 1, and 2. If I were to pick 5 numbers, it would probably include -2 as one of my x values. Alright, so now all I have to do is plug each value into my function above. So y is going to equal 4 to the -1. And remember, negative exponents, they flip it, so this is really equal to 1/4. And as a decimal, that's 0.25. Plugging in 0, y equals 4 to the power of 0. Well, anything to the power of 0 is just 1. Plugging in 1, 4 to the first power. Anything to the first power is itself, so I get 4. And plugging in 2, y equals 4 squared. That means 4 times 4, which is 16. So I get 16. So these are the values that I'm going to plot in a graph. These are my 4 ordered pairs. So making my graph over here, I made it really tall because I have to go all the way to 16, so I'm going to start that way first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh dear. Okay. I'm going to start over. Let me try that again. Make it even bigger, start lower, and make my marks smaller. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, so that's 16. I'm going to label it. And then down below, I go from -1, 0, 1 to 2. Alright, so now I just need to plot each of these points. So my first point is -1 and 0.25. So over to the left -1 and up 0.25, and here's my first point. 0, 1, I go left and right 0 and up 1. 1, 4, I go to the right 1 and up 4. And 2, 16, I go to the right 2 and then all the way up to 16. Alright, remember that we cannot touch the line y equals 0, or our x-axis. This is our asymptote. So we don't want to touch this line. We have arrows on both ends, and we're just going to touch all of our points, and then arrow at this end too. So here's my graph. Alright, let's look at number 2. Number 2 says an initial population of 175 quail increases at an annual rate of 6%. Write an exponential function to model the quail population. What will the approximate population be after 4 years? Alright, well, it has a couple of keywords in here for us, like increases, and it tells us that we have an annual rate of 6%. It wants to know how many we have after 4 years, and it tells us initially we have 175. So this speaks to us saying we're going to use our growth formula. And our growth formula, if you recall, is A of t is equal to A parentheses 1 plus r parentheses and then exponent of t. So we want to identify all of our variables. Our lowercase a stands for our initial amount, which is 175. The r stands for our rate, which is 6%, and as a decimal we move it twice to the left, so it's 0.06. And then the t stands for time in years, and we have 4 years. So I'm just going to plug all of this in. So I get A of 4 years equals my initial amount, 175, times the quantity, 1 plus 0.06, and this is raised to the power of 4. And all I'm going to do is plug that into my calculator. In my calculator, I'm first going to say 1 plus 0.06. I'm going to get an answer for that. I'm going to say equals. Then I'm going to raise it to the power of 4. Then I'm going to multiply it by 175. And when I do that, since I want to find the approximate population, then I see that A of 4, my population after 4 years, is equal to about 221 quail. And that's my answer. Alright, let's look at number 3 and 4. 3 and 4 say to describe the translation of the function. So first you want to identify your parent function. And your parent function is the function that has the exponent of x. So my parent function is 5 to the x. I'm going to cross that out. So what I really have as a translation is the 1/6 in front. Since it's in front and it's multiplying, then I know it's either a compression or a stretch. And since 1/6 is less than 0, it's less than 1, but it's greater than 0, then I have a compression. I have a compression by a factor of 1/6. Alright, let's look at number 4. Number 4, first identifying my parent function. Again, it's my number that has an exponent of x. So here's this 1/5 to the x, so I'm going to cross that out. We have this 4 in front, and again, a number in front that's multiplying is either a stretch or a compression. Since 4 is greater than 1, I have a stretch by a factor of 4. And that's just one translation. My other translation is this plus 3. That's on the back end. And I'm adding 3. It's a normal size 3. I'm not adding it to the exponent. So that's going to be a translation going up or down. Since it's plus 3, it's going up. So I have a vertical shift up 3 units. And those are two translations in number 4. So the plus 3 was a vertical shift up 3 units, and the 4 in front is a stretch by a factor of 4. All right, let's look at number 5. It says evaluate e to the 2.2 to 4 decimal places. Well, for this problem, all you have to do is plug it into your calculator. There should be an e to the x button, and so you use that key, you plug in the 2.2 for x, and we're going to round it to 4 decimal places. So you should get, according to my calculator, 9.0250. Again, it says 4 decimal places, so make sure you go out 4. Alright, number 6 says, suppose you invest $900 at an annual interest rate of 3.4% compounded continuously. How much will you have in the account after 7.5 years? Our keywords here are compounded continuously. That tells us that I'm not going to use the growth or the decay function. I'm going to use the PERT formula. So A of t is equal to a capital P e to the RT. And some things I want to notice, it says 900, says an annual interest rate of 3.4%, and it says 7.5 years. Alright, so I want to identify what each of my variables stand for. My P is my principal amount, or my initial amount, so 900. E is just E, I'm going to use that letter in my calculator. R stands for my rate, so my interest rate is 3.4%, and moving my decimal twice to the left, I get 0.034. And T stands for my time in years, and we have 7.5 years. So now I'm just going to plug all of this into the formula. So alright, sorry, it kind of cut out. So what I plugged in was A of 7.5 years is equal to my initial amount, 900, times E, but E is being raised to 0.034 times 7.5 power. So when I put this in my calculator, I'm going to put in my E function. In my power, I'm going to make sure that I use parentheses and say parentheses 0.034 times 7.5, close parentheses. I'm going to see what that's equal to, and then multiply it by 900. And since we're talking about money, I get $1,161.42. Alright, let's look at number 7 and number 8. Number 7, 8, they say write the equation in logarithmic form. So you just have to recall your exponential form, which is saying by to your x, so b to the y is equal to x, and changing that to your logarithmic form, which is log base b of x is equal to y. So remember, the logarithmic form is in alphabetical order, and then what we have in 7 and 8 is exponential form, which is by to our x. So if you just identify your b, y, and x, then it might make things a little bit easier for you. So your 3 is your b, your 5 is your y, and the 243 is your x. So changing forms, we have log base b, which is 3, to the x, which is 243, is equal to your y, which is 5. So here's our logarithmic form. Oops. There we go. Alright, number 8 is doing exactly the same thing. 8 is our b, the 4/3 is our y, and 16 is our x. So we have log base 8 of 16 is equal to 4/3. Alright, number 9 and 10 say to evaluate the logarithm. So our first step is to set this equal to x. Now we're going to change the form. It's in logarithmic form, so we're going to change to our exponential form, which is saying by to our x. So my b is the 2, and I'm raising that to the x power, and it's equal to 128. Now you have two choices. You can either figure out, using your calculator, 2 to what power gives you 128, or you can use your border method, and you can break down 128. 2 goes into that 64 times, 2 goes into 64 32 times, 2 goes into 32 16 times, 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 twice, 2 goes into 2 once. And you can count up how many 2's you have here. We have 1, 2, 3, 4, 5, 6, 7. So this is really 2 to the x is equal to 2 to the 7th. And since our bases are the same, we can cancel those out and set our exponents equal. So x is equal to 7. And here's your answer. Looking at number 10, we're doing exactly the same thing. So we're going to set it first equal to x, and then we're going to change the form. Now here we don't have a base, but we know that our base when not given to us is base 10. So changing the form to saying by to your x, we get 10 to the x is equal to 0.1. Now here you can do the same thing, and you can use your calculator and try to figure it out. And this one's a little bit trickier. Sorry about that. Alright, so 10 to the x equals 0.1 is kind of tricky. What you should do is change 0.1 to a fraction. So 0.1 as a fraction is really 1 over 10. And now it might be a little bit more clear to you what x would be. And you should realize that if x was 1, then 10 to the power of 1 is 10. And that's too much. If we go down to 0, 10 to the power of 0, that's 1. And that's still too much. So we know it has to be less than 0. So the type of exponent that makes your number flip into a fraction is a negative exponent. So here x is equal to -1. Alright, number 11 and 12 says write the expression as a single logarithm. So we're going to use our properties of logarithms. First of all, in number 11, we see we have numbers in front of the word log. Anytime you see that, you want to take that number and make it turn into an exponent for the term that goes with the log, for the argument. So we really have log base b of t to the 4th plus log base b of y to the 6th. Now we can combine it some more and make it a single logarithm by noticing that there's a plus sign here. We have the same base, which is log base b, so we're going to keep that like term, log base b, and the plus sign tells us we're multiplying. So we're multiplying t to the 4th times y to the 6th. And now we have a single log, and this is our answer. In number 12, we don't have any numbers in front of the word log, so we don't have to worry about any powers. What we do have is this minus sign, and a minus sign refers to division. So we keep our like term, log base 5, and then we divide 100, since it's our first one, divided by 10. And we can simplify that. So we have log base 5, and then 100 divided by 10 is 10. So here's our answer. Number 13 goes the other way around. It says expand. We want to expand the logarithmic expression. So what we see here is that we have two terms, the 5 and the n squared. They're multiplying with each other. So to expand it, we know multiplication goes hand in hand with addition. So my log is log base 6. I'm going to say log base 6 of 5, and since I'm multiplying with n squared, we're going to say plus n squared gets a log also, so plus log base 6 of n squared. Now we can expand this a little bit further because we have an exponent here, so we're going to move that 2 to the front. And then we'll have our expanded logarithm. So we have log base 6 of 5 plus 2 log base 6 of n. And here's our answer. Alright, let's look at number 14. 14 says use the change of base formula to evaluate. So what we do here, change of base formula says that if you have a log base b of m, that you could rewrite it as log of m divided by log of b. So identifying our m and b here, this becomes log of 14 divided by log of 4. And when we put that in our calculator, we get 1.9037. And here I rounded that off to the nearest thousandth. Nope, I rounded off to the nearest 10,000th place. Number 15 says solve. We have an exponential function, and we want to solve this and round our answer to the nearest 10,000th, like I did in the previous answer. So, since our bases here are 4 and 63, and we can't make them the same, I'm just going to throw the word log in front of each. So it's going to be log of 4 to the 7x is equal to log of 63. And I'm going to rewrite that, make it a little bit more clear. It's log base 4 to the 7x power. There we go. Alright, then using my rule of powers for logarithms, 7x comes to the front. It becomes 7x log of 4 is equal to log 63. And solving for x, I'm going to divide both sides by 7 log 4. Divide over here by 7 log 4. That way, on the left side, the 7's cancel, the log 4's cancel, I'm left with x is equal to, and once I put this in my calculator, and in my denominator, make sure you use parentheses there, rounding to the nearest 10,000th, we get 0.4269. Alright, now number 16. It says solve, and we want to round to the nearest 100th if necessary. Alright, whenever we're solving, we want just one log on each side. So I'm going to combine these two logs. We have this minus sign here, and that indicates division. So I have log of 4x divided by 5 is equal to 0. Now we don't have a base here, so we know our base is automatically 10. And here I'm going to change to my exponential form. So say pi to my x. So changing forms, I get 10 to the power of 0 is equal to 4x over 5. And now solving for x, well, I can simplify 10 to the 0th, that's just 1, is equal to 4x divided by 5. And to solve here, I'm going to go ahead and multiply by the reciprocal. So I'm going to multiply by 5/4 on both sides. So here the 4's cancel each other, the 5's cancel each other. So I get 5/4 is equal to x. Alright, number 17, I had these couple of practice problems in here. In class, we went over these practice problems. If you weren't in class to see those, I talked about the natural log. And natural log is written or represented with just the ln, whereas a logarithm is represented with the word log. And the difference here is the natural log has a base of e, where a logarithm has a base of 10. Now, when we're simplifying, if we have ln of e and it's raised to a power, then our answer is just that power. To simplify ln of e to the 5th, our answer is 5. To simplify ln of e to the 28, our answer is 28. So for number 17, to simplify ln of e to the 6th, our answer is 6. Alright, for number 18, again in class I did these two practice problems. I'm going to do number 18 for you now, and if you want to, you can go back and try those two practice problems to make sure you got it down. So in order to solve here, we're going to take the same first step that we would if we were solving a logarithm, which is we're going to change to exponential form, which again is saying pi to our x. So we said for natural logs, our base is e. So really we have a base of e here. So when I change forms, I'm going to have e to the 5th is equal to 2x plus 2. And in order to solve for x, I'm just going to subtract 2 on both sides. I get e to the 5th minus 2 is equal to 2x. And then I'm going to divide by 2 on each side. So what I get for x, I get x is equal to e to the 5th minus 2 divided by 2. And all I have to do is put that in my calculator. When I round this to the nearest thousandth, I get that x is equal to 73.207. Alright, let's look at number 19. 19, again, I went over these problems in class, so if you want to try them out for practice, you can. I'm going to go over number 19 though. So here we have e. Whenever you see e, you know that we're going to use our natural log, or it has to do with the natural log, or ln. What we're going to do, since we already see that this is in exponential form, it's in b to the y equals x form, we're going to change it to our logarithm form, or our logarithmic form. In this case, though, we're going to change it to our natural log form. So it's going to become ln, where our base is e, x equals y. Alright, so here, all we do, though, is, and actually, we're going to scratch that. Let's not even change forms. All we're going to do is raise each side, or put the natural log, the ln, on each side. So ln of e to the x is equal to ln of 3/4. Now from number 17, recall that this side over here, whenever we see ln of e, that it's really just equal to our exponent. So this is really just equal to x over here. This ln e cancels out, so I get x is equal to the ln of 3/4. And now all I have to do is solve. So I'm going to put in my calculator ln of 3/4. And when you do that, make sure you use parentheses around that 3/4 or you use 0.75. So x, when we round this to the nearest thousandth, x is equal to negative 0.288. Alright, and our last problem, number 20, says without graphing, determine whether the function represents exponential growth or exponential decay. Now, when we're trying to determine exponential growth or decay, our function, first of all, is a times b to the x. Remember, this b to the x is our parent function. And that's what we're going to look at. We're going to look at the b. If b is greater than 1, then we have a growth. And if b is less than 1, then we have a decay. Decay. Alright, so our b here is 7/10. So here's our b, 7/10. And we see that that's less than 1, so our answer is decay. Alright, you guys, that finishes the study guide. This next slide here, here's all of the answers. So just look back over all the answers, make sure you got them all. rewatch the video if you need to. Come in with any questions, and I'll see you guys in class.